Good evening, everyone. My name is Vikas Kumar. I am from IT Bombay, and I am here to present my work titled Ensemble Machine Learning Approach for PM2.5 Reconstruction using Merato and Long-Term Analysis for India. So, particles are affecting more people worldwide than any other pollutant and is the fifth leading risk factor for death and has, uh, has different effects like on human health as well as climate change. But due to infrastructural deficiency, uh, a dense monitoring network of monitoring stations is not feasible and as we can see here, this is the current the scenario of monitoring stations, and this is the required. As per CPCB's thumb rule, 4,000 air quality monitoring stations are recommended depending on the district level pollution population. So alternatives are required, and satellite data as well as reanalysis data sets have turned out to be one of the alternatives for it. The most prominent being MERA2, which is a multi-decadal reanalysis product released by NASA in 2017. And uh, but MERA2 does not provide PM2.5 directly, and it needs to be reconstructed from the five aerosol components, namely black carbon, organic carbon, dust, sea salt, and sulfate. If we look into the literature review, we can see that most of the studies have applied in the empirical equation for reconstruction. However, a few studies have applied machine learning and neural network approaches, and their performance is better than the empirical equation in most cases. And so, however, no such attempt has been made for India. If we look into the empirical equation, we can see that it is basically dust plus sea salt plus black carbon plus 1.82 organic carbon plus 1.375 into sulfate. However, these coefficients will change depending on the geographical location and the average surface measurements of the study area. So applying the same equation everywhere is not the right approach. So in this study, we have collected data from 335 monitoring stations across India, and we are trying to develop a machine learning model for reconstruction of PM2.5 for India. So if we have applied three algorithms, namely random forest, KNN, and gradient boosting, and on comparison of these models' performances, we can see that the random forest uh, is the most appropriate model as with the highest performance with train and test score of 0.86 and 0.74. And when the this result is compared with the empirical equation here, we can see that the R square based on empirical equation is only 0.27. However, the R square based on random forest is 0.74. And if we compare the concentration in between 1980 and 2021, we can see that the Indo-Gangetic Plain is the most polluted region in India, with and a significant shift is observed from 2000 onwards. And so, thank you.